In the last video, we looked at the sample mean of these two classes, and we said that their averages were quite similar. We also said that class B has a much bigger spread in the data than class A. So that's what we're going to look at in this video, how to calculate variance and what it means. So let's look at class A. We found in the previous video that x bar for class A, let's round it to the nearest whole number, was 65. So what we want to do is we want to measure, on average, how far are the data points away from the mean. So if we look at this blue data point, which is at 69, that's a distance of 4 away. And if we look at this black data point, which is at 71, that's a distance of 6 away. And we could also do the same for this red data point to the left of the average, which is a distance of 10 away. So what we want to do is we want to try and work out what's the average distance. So what we could do is we could work out each of those distances and then divide by 10 to work out the average. So let's try and write down a formula. So variance is equal to, we're going to do each of the x values, take away x bar, and that's going to work out the difference between the x value and x bar. And we're going to do that for each of the x values and add them together. So we could write that as the sum of xi minus x bar. And if I'm writing this formally, I should write, we're going to start at the first data point and go up to the nth data point of this n data points in our sample. And then we want to work out what's the average of those distances, so we divide by how many data points there are, divide by n. The problem with this is, if we look at these three data points that we looked at before and work out what this formula would actually give us on the numerator, if I do x take away x bar for the blue dot, I would get plus 4, 69 take away 65. If I do the same for the black dot, x take away x bar, I'd have 71 take away 65, which is plus 6. The problem comes when I look at this red dot, which is at 55. If I do 55 take away 65, I'd get minus 10. So if I just worked out the numerator just for these three data points and I added together these distances, I'd have 0 if I added them together, because the minus 10 cancels out these positive 6 and positive 4. So the way that we avoid minuses in our calculation is we actually square the distances. So the numerator is the sum of the squared distances to the mean. So if we were to calculate that variance for this data, we're going to start with the first data point, x1 equals 86, and we're going to do 86, take away x bar, which is 65, and square it to make sure it's positive. And we're going to do the same for each of those data points and add up the answers. All the way up to 34 take away 65 squared. And then we want the average, so we're going to divide by n, and n in this case is 10 data points, so n equals 10. And if we work that out, we'd get that the variance is 292.7. The problem with this, using this statistic, this variance number, is that we've squared the distances, so it doesn't actually give us a good idea of the average distances of the points to x bar. So it makes sense to square root the variance and talk about what's called the standard deviation. So if we work out the standard deviation here, we're going to square root the variance. And if we did that, square root of 292.7, we'd get that the standard deviation is 17.1. And that gives us you can kind of think about that as the average distance of each data point, the average distance of the data points to x bar at 65. In your formula book, you'll see this written as SXX over n. instead of that numerator. So whenever you see SXX, what SXX is it gives you, it's the sum of the squared distances to x bar. So if you look at the formulas that you get given in your formula book, we've just looked at this formula for standard deviation, SXX over n. There's an equivalent formula which can sometimes be a little bit quicker to compute. And actually in your exam, you often just get given the sum of x squared and the sum of x. So you need to know how to use this formula on the right. And in the next video, as a bit of an extension, we're going to prove that the two formulas are actually equal to each other. So let's just see how to use this new formula to calculate the variance. So we're given the formula for standard deviation, but I'm going to work out the variance first, so I'm not going to square root it yet. So the variance formula, the new variance formula, it's the sum of x squared over n minus x bar squared. And they've not used the I notation in the formula, but really what we're doing is we're doing, with this sum, we're doing it from I equals 1 up to n. But that makes the formula a little bit messier. And it's important that you understand that this sum, we're only summing up this xi squared, this x squared term. The minus x bar squared is separate. So we're going to have to work out for our data for class A, what is this numerator, what's the sum of the x squareds. So let's write that down. The sum of the x squareds. We're going to take each of the x values, square them, and add them together. So we're going to do x1 squared, which is 86 squared, add on x2 squared, 49 squared, all the way up to 34 squared. And if we work that out, we get 44787. So that's the sum of the x squareds. Now recall from last video that we had worked out that x bar for this data was 64.7. So now we can substitute into our formula. We're going to have the sum of x squareds, which we've calculated as that, divided by n, the total number of data points, which is 10 in our sample, and then subtract x bar squared, which is 64.7 squared. And because these two formulas are equivalent to each other, you're going to get exactly the same answer for the variance, 292.7. And obviously you could work out what the standard deviation is by square rooting that, like we did before. In the next video, we're going to prove that these two ways of calculating the variance are identical to each other. And then in the video after that, we're going to use our calculators to calculate standard deviation and variance.